Okay, this is a concept that we've hit before. I'm not going to spend too much time on it. I'm just going to show you the proofs. We've done the derivatives of sine and cosine. I've shown it to you in class. You've already seen it on the quiz, but I'm also wanting to just kind of show you the proofs one more time. So let's just kind of go through this real quick. Remember some of these basic rules with derivatives, and remember the expansion rules of sine and cosine, and remember our limit rules for sine and cosine. All right, with all that information, we can prove the derivatives, and that's all I want to do for you guys. Let's first prove the derivative of sine of x, and so we're going to do this through the definition of the derivative, and let's just go for it. So we got the limit as h approaches 0 of, let's do f of x plus h, which in this situation would be sine of x plus h, minus sine of x all over h. Okay, let's use those expansion rules that I gave you on the page before to expand sine of x plus h. So we got the limit as h approaches 0, and sine of x plus h would expand as sine x cosine h plus cosine x sine h, and then we still have a minus sine x up there, all over h. Okay, you got to get a little creative here. What I would recommend is getting your sine x's together and actually separating it out as two fractions. I know that you've seen this before, but I just wanted to have it for you in one spot. Okay, so we can actually write this. If I move this sine x over here, I could write this as sine x cosine h minus sine x. And I'm just going to put that over h and then do plus, because if they all have one denominator, I could write it as two fractions with common denominators. And so I'm going to write this as cosine x sine h over h. Alright, I can now evaluate these limits separately, and everywhere that there's just an x value, I don't really need that in it. So I can actually factor out a sine x, and since the limit is only evaluating as h approaches 0, it doesn't have anything to do with an x, I can actually write it out in front of the limit notation. And so what's left? Well, what's left is a cosine h minus 1 over h. That's the whole left. Now, plus, I'm going to put this limit symbol over here with this guy. And the same thing is true, though. This cosine x I could factor outside. So I'm going to write this as cosine x, the limit, as h approaches 0, of sine h over h. Alright, now when it's written like this, hopefully you see what I did here. I factored the sine out, put it out in front, because it's not relevant to this limit notation. Well, this is one of my little shortcuts that I should already have memorized. This is 0. So essentially what I have here is I have sine of x times 0 plus cosine of x. Well, this is also one of my notations that I should recognize. It's just 1. So cosine of x times 1. Well, anything times 0 is 0, and so that's how we get cosine of x. Alright, so there's the proof of that one. And we're good there. Let's go ahead and go to the next page. Okay, and this is one you should be able to do on your own. I'd encourage you to try it. Maybe pause the video and just try it, and then I'm going to do it in just a second here so you can check to make sure you did it correct. Okay, let's use the limit definition. The limit as h approaches 0 of cosine x plus h minus cosine x all over h. Okay, let's use the expansion rule for cosine of x plus h, and so we get the limit as h approaches 0 of, this would be cosine x cosine h minus sine x sine h minus cosine x all over h. Again, I want to reorganize this as two fractions, and I can separate it out as two limits as well. So let's put the cosine x's in front. So first of all, I noticed that these two I could write together. So I'll go ahead and write it like this. And that leaves me with just this part here. So I'm actually going to write minus the limit as h approaches 0 of sine x sine h. And I mean, it just depends how you want to write it. I'm actually separating out the limits. I didn't do this last time. I didn't do it to the next step, but it's okay. It doesn't really matter. We're going to go ahead and do it on the next line here. We're going to factor everything out that's a cosine x or a sine x. So first off, I can pull a cosine x because, again, the limit as h approaches 0 has nothing to do with an x. So I can pull the cosine x out of both of these, leaving me with the limit as h approaches 0 of cosine h minus 1 over h minus, and here I can pull a sine x out, so minus sine x of the limit as h approaches 0 of sine h over h. Okay, from here, just recognizing my patterns, this is 0, so I essentially have the cosine of x times 0 minus the sine of x times, well, this is one of my patterns that I already know, and it's 1. Okay, so there we go. I essentially have 0 minus the sine x, which is negative sine x. And so that's where we can see this pattern comes from. And you could repeat this process for negative sine x and negative cosine x, and you would see where that circular or cyclical derivative comes from. So once again, it's going to look like this. If you start with sine, and we were just taking the derivative of sine would be cosine, the derivative of cosine would be negative sine, the derivative of negative sine is negative cosine, and then the derivative of negative cosine starts back again at sine. This is a pattern you want to be familiar with because you're going to see it a lot. Alright, see you guys on the next video.